All right, so when it comes to gravity, there's three basic proofs that I've come up with to explain the phenomena of gravity and how it can be described as anti-gravity. The three proofs are buoyancy, density, and geosynchronous orbit. Right. So this is basically what I came up with, or this is how I see it in my mind. First, one of the most fundamental principles of gravity that we take for granted as bipedal creatures is that when we walk in opposition to gravity. Walking is a controlled fall, right? When you walk upstairs, you're falling upward. So you're falling in opposition to gravity, right? We don't think about it logically, but that's literally what is occurring. To climb upstairs or to descend down hills, you're literally falling with or against gravity. So the very act of walking uphill is using gravity to move away from its source. Gravity pulls everything to a common center, and as you move up a ladder, you are literally using gravitation to move away from its source. The same holds true with aerodynamics. Lift occurs because the foil of the wind of the wing creates a negative pressure above the wing and a positive pressure below the wing. The air below the wing pushes up to try to feel that negative pressure above the wing. That's important because it speaks to both density and buoyancy. Density is the behavior of mass that is greater moving toward the common center of gravitation and mass that is lesser moving away from a common center. So solids, liquids, and gases always organize themselves gravitationally with the heaviest components or the densest components at the center and the lightest components on the outer edge, right? Buoyancy is the repulsive force of a lighter or less dense material being pushed out of a denser material. So those are two forces of anti-gravity. Those are two forces that show that gravity behaves in a fundamental attraction and repulsive manner or nature. Now here's the conflict. Gravity universally is a force of attraction. That means that the Earth pulls everything toward its common center, and the Sun pulls everything toward its common center. The Earth is falling around the Sun, and the Sun is falling around the Earth. The Moon is falling around the Earth, and the Earth is falling around the Moon. I'm not anti-gravity. Um, Zero synchronous orbit is actually the result of, um, or the way I see it in my head, zero synchronous orbit around two massive bodies is actually gravitational repulsion. So if you think about it, the Moon and the Earth both have gravitational pulls, right? They both have gravitational pulls. So the question is, how is it possible that at their centers, how is it possible that at some common center between them, there exists a place of neutral gravitation? If you flip the forces, if you flip the gravitational force so that the Earth's gravitation and the Moon's gravitation are pushing away from each other, they should move apart, but instead they just create a place of equilibrium. So their force of repulsion balances out at the zero synchronous orbit, and that holds true to everything. That holds true to the sun, the moon, everything. And the reason why we don't see it, the reason why humanity doesn't see that force, or the reason why we don't calculate that force, is because we don't run the numbers for it. We don't need to. We don't need to run the numbers for that because And how is that? Yeah.
I think that might be how gravity is actually being created. And it has a lot
Through
of
therm.
different ways. Because I know that it. See, the thing is I'm, for me, it's always that there's an action. What is the action? Look at you and I both know that when you like everything seems to function by something moving and something is doing something. But the only thing that I know that the way this Earth is, first of all, the Earth is in space, which is extremely cold. Then you have the sun shining on the Earth, and just like when metals will contract and what is it? What is the word? Contract and
Expand.
expand and contract. And my thing is, we have a lot of elements in the planet. You know, like in most celestial bodies, like rocks and all kinds of materials and stuff. So if that is taking place, a constant, attract, because what I'm trying to do is find what is the motor of the, what is the actual, the functioning that's creating this thing that we know as gravity. And there's a possibility that the contraction and expansion of the Earth could actually be creating this gravity. You know what I'm saying?
Mm-hmm.
Because remember, that action creates electricity, and that action will create frequency and also waves.
Mm-hmm.
And the waves could be what's actually pulling. So what I'm saying is, all I'm trying to do is to figure out what exactly what is the motor force behind the so-called gravity? What is creating the gravity? And it could be that the contraction and expansion of the planet itself, swelling and because it's doing that. You know what I'm saying? And could you imagine the amount of energy and what is that energy doing? Because the Earth is doing that. People don't know it. That's why there are earthquakes and stuff. The Earth quacks and stuff because there's an expansion and a contraction.
Yep.
You know what I'm trying to say? And these plates moving and stuff. And we already know certain. Because there's probably metals that we haven't even discovered. There's probably material so deep down in the Earth that we haven't even dug down to that we don't even know. You know what I'm saying?
Mm-hmm.
So to me, after listening to what you're saying, and I'm in my mind, when I say, how is it made? What is it? Well, that could be what's actually creating it. Because we ain't buying that spinning thing, because that's a centrifugal force. But you know what? Contraction and expanding, you and I both know, all them kids have little lights in their shoes, they walking around, you know how that works. You know what I'm saying? There's a little chip on there that actually will create electricity just by vibration. Vibration is what's powering that shooter people. So if the Earth is naturally doing that, swelling and collapsing and swelling and collapsing, well, you and I both know an energy force is going to be created. And guess what? That force, more likely, is going to be gravity. And if that's the case, then that means that the composition of gravity would basically be, when you mention about electricity, signal, and frequency. Because we're talking about, and then the waves, like when you look on a telescope and see the waves.
Mm-hmm.
And I'm thinking that, and all of this is and it can all be just because of the contraction and the expansion of the Earth. That is where it's generating this gravity. You know what I'm saying?
Yep.
Well, who knows? Wouldn't that be interesting?
It would. But like I said, let me get out of here and get to running, and we'll have this discussion again tomorrow. So a little bit of.
Trying to figure out what's powering this gravity.
Mm-hmm.
Okay.
Yep. That actually that was actually very helpful. So.
Okay. Alrighty. Okay. Well, go on do your run, and I'll just talk to you tomorrow.
That'll work.
That way you can dream on it or think on it and stuff like that. Because I'm still trying to figure it out, but that's why I just came up with that just by listening to what you were saying.
Oh, all right. Yeah, it's good. Yep. I'm gonna definitely explore it. And since I recorded it, I can always just listen to it again later too. So.
Yeah. I never heard nobody talk about how it's actually made, other than the centrifugal spinning of the planet. But I think something else is going on.
Mm-hmm.
To me,
Yep.
Maybe that's where the source of the gravity is probably coming from.
Yep.
Who knows? All right. Well, that's my little theory.
All right. Appreciate it.
I just came up with it today because I never thought about it until I'm talking to you.
Mm-hmm.
Okay.
All right.
I'll talk to you later.
In a minute.
In a minute.
Bye.
And to what what we were talking about, the gravity, I don't know, the gravity phenomenon or the gravity, the whole gravity subject matter. And I was just thinking that just something came to mind that what could be also adding to what gravity is, the composition of gravity. You know what I'm saying? Being the force that it is, because you and I both know the way physics work. We talk about it, for every action as an equal opposite reaction.
Right.
But we also understand that everything seems to act upon itself, and then you have what we refer to as anytime when something happens, like in physics, there's always like a byproduct. It's just like that's just a natural theme, the scheme of things. You know what I'm saying?
Mm-hmm.
So all I'm saying is that even when it comes to like mechanical engineering and all this kind of stuff, dealing with mechanical stuff, when you have torque, and if you have depending on mass, you're gonna have when you get momentum, like when you try to slow something down, you know what I'm trying to say, inertia and all this kind of stuff. So with that said, I'm just curious too. There could be a possibility that water may be powering what we refer to as this gravity. You know what I'm saying? Because I was just thinking about when they was talking about how the Earth is spinning.
Yeah.
And I'm gonna tell you what's interesting. If the Earth is spinning, and you and I both know how water responds to being spun. Now, the thing that's in contradiction when it comes to water being on a situation that is spinning, usually what water will do will move in the same direction of the spin. But in the oceans and stuff, waves are not doing that. Waves are going back and forth and side to side. You know what I'm saying? So think about it. When they say we're spinning as like this big ball, and this probably be something that the flat earthers might jump on the bandwagon and run with. You know what I'm saying? But the thing is, if you took water, put it in a container and spin it, the water is going to move in the direction of the spin, no matter what you're doing. You know what I'm saying?
Mm-hmm.
And so with that said, now the question is this: what exactly is the water responding to? Because we notice how we say water will run downhill because of gravity. Okay, so is water is like this? What exactly is acting upon water? Is it the actual gravity, or is it the wind that is being produced? You know what I'm saying?
Mm-hmm.
And that's another thing too. Wind. Wind is very unique and mysterious too, because I don't think quite understand wind and how that works. Like for instance, notice how like on a nice day where it's still, you almost like it's no wind. You know what I'm saying?
Yep.
Then there come a time where you get a breeze, a real nice calm breeze. So the question is, how all this happening? You know what I'm trying to say? Because it's almost like the system is so perfect. We know something is acting upon something. But I just wanted to add the part to you with the gravity is water maybe playing a part in creating the what we know of as gravity. Because the question is, what is the byproduct? Well, not the by. Okay, I'm trying to figure a way how to put this. Okay, because there's another word. I'm trying to. What is the word? It's because by is something like that's addition to. You know what I'm saying? Like for instance, when we know that we get oxygen from plants. I'm sorry. Yeah, from the plants, and the plants get carbon from us. You know what I'm saying?
Right.
So the thing is this. So the question I'm trying to make is, and you probably find the word, the appropriate word for it is, but that is this. Okay, say for instance, we know for a fact, just through studying and stuff, and you good with the math and stuff, let's just say that we found that, and this seems to be always the case when it comes to physics, and that is, let's say that gravity is a byproduct of something. So the question is, a byproduct of what? You know what I'm trying to say? Does that make any sense?
Yep.
Because you and I both know when it comes to forms of energy, there's always the before the by. And that's why I was trying that word, like what is like if gravity is the byproduct of something, of another form of energy, the question is, what is the initial whatever that is given off of that's producing the oxygen? I'm sorry, the gravity. Does that make any sense?
Yep.
Okay, so so I was just thinking that there's a lot more going on, because one thing about physics, when we talk about, situations acting upon other situations, and for every action, there's an equal opposite reaction. Now listen to that, an equal opposite reaction. So the question is, it seems like everything has a source that is coming from something. Meaning that our oxygen, it's like this. You got two organic sentient beings, like we as the humanoids walk around, and then you have the planet. So now the plant is giving off the carbon. We're giving off the plant giving off the oxygen, and we're giving off the carbon. You know what I'm saying? And so we kind of need each other. Okay. So we're acting upon each other. So the question to where do the plants primarily getting their carbon? Now we ain't saying all their carbon, you know what I'm saying? But we do know that the carbon doesn't have to come from humans per se, because there are other animals on the planet or other situations that is creating carbon as well to feed the plants. It ain't just us, you know what I'm saying? But my point being is, let's say this. Let's say, okay, we know what is gravity, what is the source of it, how it's being created. And then if we lean over to physics, well, one of the questions we have to ask ourselves is, what is the chances of gravity being a byproduct energy? So the question is, a byproduct from what? What energy is existing that is producing the gravity? So what's going on that's taking place? You know what I'm saying? So, and it's funny because a lot of times, like for instance, we can't see the gravity, we can't touch the gravity, but we know that something is holding us down, because if you go out into space where there is no gravity, you will float. So the question is, that's approach gravity as a byproduct. Then the question would be, a byproduct of what? Do you see where I'm going with this?
Yep.
Okay, because I noticed when you hear, like even these sci-fi movies, like when you remember I told you, I don't know what gravity is. Remember I honestly told you that?
Yep.
But you'll go online and you get these white Caucasians just telling you all this stuff on what they think gravity is. You see? But then when you ask, well, how is it created? They can't really say why or how. And you see the approach that I'm taking?
Yep.
Because I think I got a better, because you and I both know how physics is. It seems like everything seems to be, it seems like everything seems to produce a byproduct. No matter what you do. And like, well, that's not true. My thing is, okay, if I sit up here and burn a house down, what is the byproduct? Ashes that's left behind from the burn. So, and even with the ashes, now the ashes, you can burn a house. That's when you burn a house completely down to the ground, and all you have is all this black stuff. What we know as ashes. Well, you and I both know that you can take those ashes and have no idea what exactly, someone can sweep those ashes up and put it in a container and not tell you that was actually came from a house. You know what I'm saying? And you as a scientist, you can take that ashes. The fact that you look at it, and the first thing in your mind, not in your mind, but your eye and your brain will process, that this looks like an ashes. Then the second thing will say, okay, what produces that? What actually produces ashes? Well, a burn. Okay? So you say, okay, we know that a fire burns something. This something, we don't know what it is because we have ashes. Looking at the color of it. And we started thinking like, certain composition of materials will burn. They will burn. It's like even in that burn, you notice how you get different colors, because material react towards being burned differently, you know what I'm saying? So all I'm saying is, look at you put under your microscope, start looking at the composition, meaning on an atomic level, start figuring out what the ingredients are, and before you know it, you'll say, well, I tell you what, I'm still not sure what this is, but what I have is a combination of a lot of stuff, like a lot of elements. What I would say is I see there's organic stuff in here because it's like wood material or whatever that I would have to say is probably, the signature would be wood. Also, I see some inorganic stuff. It could be like, I'm pretty sure it could be glass or plastic or something. You know what I'm trying to say? Yep. So you'll say, well, I'm still not sure exactly what this was, but I know what it is. It's not like it was an animal that burned up. We don't have the remains of like an organic, like an organic, like a humanoid or an animal or something like that. But there is some organic material in there, and it's more like like a plant-like, meaning a tree or something. You know what I'm trying to say? Because people build out of wood. I mean, build houses for the most part out of wood. So all I'm saying is, if we start looking at gravity as a byproduct, because energy, everything seems to act upon something. It's like when you get, like when we talk about inertia, you know what I'm saying? So it's like everything seems to have something that's either creating something or reacting. Just like when I say creating electricity, I'm not actually creating electricity. You know what I'm saying? It's just that a magnetic field, when you cross it across metal, and then the metal is coated with an insulation. Well, what happens is instead of the because they call it inducing, meaning that when you take the magnet and cross a piece of metal across it, well, what's going to happen is the electron is going to just shoot through that piece of metal. You know what I'm saying? Yep. However, if you take that piece of metal and coat it with something, making it a little difficult for the electron to actually, to move out of the metal, then what happens is it will come out on the other end like a water hose. You know what I'm saying? So you're not really creating anything. You know what I'm trying to say? Yep. So all I'm saying is that the interesting part would be to find out what is it that is going on, and the result is gravity being produced.
So what I've been doing with my theory, or the way I'm writing my thesis, is that what you just described about the electron, well, that's the gravitron. The gravitron behaves the same way that the electron behaves. And the gravitron produces the same type of force that the electron does for gravitation. And what I did for gravity was you have electricity and you have magnetism, because you have magnetism. Remember that video I made? The when an electron orbits an atom, it generates a magnetic field, and when an electron travels through a wire, it generates an electrical field. So the graviton does the same thing. When the graviton orbits the atom, it generates a gravimetric field, and when a graviton travels through space, it generates a gravitational field. And so, no, it generates an inertial field, and then those two together give you the spectrum of inertial gravimetrics. Because that's how I describe it,
Well, actually, you know what? That's a good one, because the thing when you mentioned about the graviton, and my thing would be, now, I don't know a lot about the graviton, as an atom, but like I say, remember I talked about the quantum physics stuff? Well, put it this way. The thing is that could be it. When you mention the graviton, the graviton being what it is, meaning that the byproduct would be gravity. And the thing about it is, the question is the source of the graviton. So my question to you is, where is this graviton coming from? How do
So
you produce it? Or not you don't produce it, but how do you attract it? Or what could you have in place that will attract it? Or what,
the
how do you achieve it? Go
graviton,
ahead.
the graviton is attracted to the neutron.
Okay.
It's the remember opposites attract and like charges repel. The graviton is attracted to the neutron, and it's the same. The neutron is to the proton as the graviton is to the electron. So the graviton orbits the neutrons, and you know how um atoms can be ionized. You know, you've heard that term about ionizing an atom because it can have
Right.
more or less electrons.
Right.
Well,
That's
atom
why I need.
right atoms form isotopes by having too many neutrons. The isotope of an atom behaves just like the element itself, but that neutron gives it more mass. So isotopes are the ionizing equivalent of it's the ionizing equivalent for matter. I mean for gravitation, as electrons are to electromagnetism, and that's pretty much where they come from.
You
They're
know what?
they're generated by they're generated by losing a particle, a subatomic particle is both mass and electricity. It's both. When they're balanced, when the two are balanced, you don't get anything. You know, you just get because it doesn't interact with our because our equipment measures electromagnetic interactions and we ignore the mass. We just ignore the mass. It's like a car driving down the street. You're looking at the speed of the car, but you're not calculating the resistance of wind because you don't need to. You just ignore that part of it. So you're seeing how fast and how much power it can produce, but you're not calculating its movement through the atmosphere. You're not calculating the resistance of its tires in relation to the road. We ignore that part of the equation. So when we do our quantum physics, when we're exploring the electromagnetic component of matter, we're ignoring the mass part because we don't have equipment capable of measuring mass exclusively, you know. And that's pretty much how I describe it.
I lost my train of thought. I hate when I do that.
Oh, sorry.
Yeah. No, go ahead. It was. I hate when I do that.
Yeah, sorry about that.
Yeah.
But yeah,
No, go ahead. Go ahead.
but that's how it works. The graviton and the neutron are the force carriers for gravity.
Yeah.
And the
Okay.
graviton,
Remember what I had.
uh huh. Go ahead.
Yeah, remember I had pointed out about, everything seems to, in physics and stuff, no matter what the situation is, seem to always produce a byproduct. You know what I'm saying?
Yeah.
And the byproduct of electricity is magnetism. That is a byproduct of electricity. Because if you have the instruments to read a magnetic signature, you can take that signature, that piece of equipment, and you go to any power cord that you're using, probably TV, whatever, it doesn't matter, that's got energy flowing through it, and you will actually detect, the detector lets you know that there's a magnetic field that is actually being produced. You know what I'm saying?
Yep.
So when you mention the graviton, and I'm thinking that, and then on top of that, it's like just like you take, you ever notice how when you talk about magnets, when you like I don't know when last time you bought a magnet, but when you buy a magnet, the description of the magnet when it says rare material,
Mhm.
then you know what the magnet is made out of. So the question you have to ask yourself is, what exactly is rare material? You know what I'm saying?
Yeah,
So with that said,
they're made from rare earth metals.
yeah. So my point being is this: they understand that there are material, rock type material that like the demium magnet. How do you say that? You know what I'm saying?
Mhm.
That I don't know. I don't. That's a very powerful magnet. I don't know if you ever come in contact with them, but the material they spray it down with whatever, but it's actually not really silver. You know what I'm saying? But because they're brittle, real brittle. The thinner they are, the brittle they are. Okay, but my point being is this: now they are rare materials that they pull out of the earth that could be, you know, you can magnetize it. Actually magnetize it, and the magnetism will last for years. You know what I'm saying? And so, which is interesting in itself. Um, so, saying is this: to jump back on the graviton, and the question is where exactly are the gravitons coming from? And you explain that. Okay. Now the thing is this. Now, when everything is because everything tries to go, the thing is, one thing I find that's interesting about nature and physics and stuff, especially nature, everything seems to want to function in a calm state, meaning everything, when we talk about inertia, everything likes to respond to an inertia, but a steady still. It's like nothing seems to stand still, but everything needs to be calm. Like we mentioned about an ion. Well, an ion is when you begin to kind of mess with the atoms, adding more atoms into the orbit. You know what I'm saying? And not atoms, but the electrons.
Yeah.
And so they'll start pushing off stuff. That's when you start getting your current and all this kind of stuff. And when everything's calm, you got a flow. You just got a flow. But the thing is the Earth being what it's made of, because we don't really know what the Earth is made of, and we're like, that's not true. My thing is, until you dig to the center of the Earth, you can never know. You know what I'm saying? And last I remember, we have not dug to the center of the Earth yet. Now, I ain't saying that we never will. I ain't gonna say we won't be able to do it. But as far as I know, we have not done that yet. We have theories on what the center is. You know what I'm saying? But anyway, my point being is with the graviton and magnetism being what it is, there's a possibility that that the graviton is hitting a material, or not necessarily hitting a material, but has over the like millions and millions of years has been absorbing all kind of electromagnetic energies and stuff like this. And like how we have static electricity that's just kind of in the air, it seems like.
Mhm.
Well, the thing is this. Remember you made mention about the sun being a gigantic fusion reactor, basically. You know what I'm saying? So the thing is this. Now, when they talk about sun rays, you and I both know that a light ray has energy in it. You know what I'm saying?
Yep.
Not just about the look of it, or they call it there's something I'm trying to think of the other name. They call it the when you're looking at light. But anyway, light has electro energy in it too. So this thing about when you mentioned about and us too, we play a part in this too. You know what I'm saying? As far as our makeup, the atomic particles in us that plays a part in us sticking to the earth. Because the thing is this: what could be happening is we may be looking at gravity as this big gigantic force that's wrapping the earth and holding us down, and that might not be the case, Mr. P. What it is we being held down individually. You know what I'm saying? Because of our electromagnetic makeup, and because of it's like go back to the magnet situation. You know what I'm saying?
Yeah.
So the bottom line is the forces of gravity is not what we think. It's not a big gigantic one fit all blanket. It means that we may individually be responding to gravity with just based on our atomic particle makeup, meaning that we can all be little individual magnets for what you talk about the gravitons. So that's why we're sticking to the planet. Not just Earth, it's anything and everything, all minerals that's on the planet has its own makeup. And that's the reason why, because you either have more or less. And that's why a feather will float, not to mention the weight too, the atomic weight. You know, so and that's how I'm starting to see, because we have always thought that, or think that the Earth is just one big blanket of gravity, and it may not be. It might be, you know, like if I took a big piece of, look at it, if I had a piece of metal, and here, now this is the trip that part. If I had a piece of metal, now the metal that I have is not a magnet. Okay? Because people are like, well, we use stick, no, it's just a piece of magnet. Just a big old chunk of metal. However, a magnet is known to stick to metal. You know what I'm saying? So most people say, well, because they say that the Earth has a magnetic field. Now the question is, how strong is that field? It might not be that strong. And guess what, Mr. P? It don't have to be that strong. You see what I'm saying?
Mm-hmm.
Because it goes back to what you had mentioned before about mass, the size.
Yep.
You know, because you and I both know magnetic field can get so strong. It's kind of like I always think about the cartoon you used to watch, the Dragon Ball.
Mm-hmm.
Goku be doing that exercise where he could increase that he was in. He was increasing the gravity. He was doing his, you know, his workout.
Yeah.
Well, that's kind of like what will be happening. But the thing about it is, so to make sure that everybody is getting the right amount of gravity, then the only way that can take place is it would have to be individualized. Because you and I both know it can be very dangerous to just say the Earth has 100 tons of gravity, and not everybody can handle that. You know what I'm saying? So I think that the gravity may be, you know, it's already an energy already here on the Earth on a magnetic field when you mentioned the graviton. So the bottom line is, you and I both know we have a lot of we have a lot of minerals in us anyway, like copper, what's the other, iron, and zinc and all these other kinds. You know what I'm trying to say? So that's probably okay. Look at it like this. Remember I made the scenario about the Earth being a tropical, and we are the magnets. Well, if the Earth is a magnetic, like if the Earth is functioning as a as a magnet, and we could be the metal that's sticking to the Earth because of our atomic makeup. We have all this lead in us, not lead, I'm sorry, the iron, and then on top of that, the energy that's flowing to us, through us, like you mentioned about the graviton, that is interacting with the magnetic field of the planet. So the gravity could be actually kind of personal. It's probably an individual thing. I mean, it's there, you know what I'm saying? It's like you being in the ocean. Everybody don't float like everybody in the ocean. You know what I'm saying? Even though it's there, but your interaction with the ocean is individual. It's personal. And I think that could be what's going on with gravity. Because we're looking at it as one big entity, one big chunk of energy, and it may not be. It might be a situation that's just kind of there. And because of our makeup and how atoms try to act upon itself or each other, like when you mentioned how the gravitons are attracted to I think you said the proton, electron.
One more time.
I said when you were mentioning about the graviton was attracted to
the neutrons. Yeah.
The neutrons, okay, that they and that's a situation where they're attracted. So you and I already know how that works. So you talking about when we talk about attraction, we talk about the people got to understand when we talking about this stuff. These atomic particles are moving at light speed or more. You know what I'm saying?
Yep.
So when you have, there's not even a number. You probably could, but you're talking about when you talk about the graviton attracted to the neutron. You know what I'm saying? Like the neutron, right?
Yeah, that's right.
Okay, so we're talking about it wouldn't be like one. It would be like a billion trillion of them moving at a fast rate. You know what I'm saying?
Yep.
And with that, and then you have these, because remember, we have metals in us. Just like everything have a composition of some kind of metal in it. You know what I'm saying? So that could be what it is. We could be, the Earth is the magnet, we're just the little pieces of metal that stuck to the earth.
Nope.
and where all that energy is coming from, remember I mentioned we have light beams that's hitting the planet, so we can get a lot of our fuel. Remember now, we have an ionosphere. Ain't that interesting?
Yep.
Okay. Well, anyway, that's why I called you. I just wanted, and for some reason, water came to mind. So I don't know why that came to mind, but I figured we'd add that too. But I think I would love to add a lot of stuff, trying to make sense of stuff as an engineer, because we can always, because you know me, I'm a trial, I go the trial by error thing.
Yeah.
So just add everything, and then begin to start eliminating things.
Yep.
That just don't fit the puzzle. Because right now, because the thing, because I find that I noticed when I had all my life when I would make things and build things, on an engineering level, I always noticed that every time when I dismiss something, they say, "Nah, that can't be," and go, and use everything else that I kind of figure should be, and then I started noticing that the things that I usually dismiss is usually the thing that was the key. Just like the perfect example would be when I was telling you about the guy who was fixing my car, and he was just telling me how he's a master mechanic, because I was doing this everything again. But he was just going on and on about all this knowledge he had. And then I went and bought, because my windshield wiper went out, so I needed a windshield wiper motor. So we go to the buy the windshield wiper. I'm the one paying for it, you know what I'm saying?
Yeah.
And I remember him doing all this talking, and I'm listening to him. And then I remember him getting back to the house, he bravely tore up the car just trying to get this damn thing in, which I wasn't happy about. I guess they didn't teach you about that and being top gun engineer 101 or whatever. You missed that part in the class. But anyway, he sat up there, he did all that. And he put it in, watching him, he just doing his thing, trying to explain stuff to me. And then he was done. He told me he was done. And then when he said he was done, I noticed it was a screw. So I told him, I said, "Well, what about this screw?" "Oh, no, you ain't got to worry about that screw, I said, and it was funny, so I said to him, I said, "Well, I don't know nothing about what you're doing, because I don't do this kind of stuff." I said, "Well, one thing I do understand is this. Engineers are not artists. They don't have nothing, they don't have, when they do stuff, everything has a purpose. You know what I'm saying?"
Yep.
I said, "So I'm pretty sure this screw serves a purpose." And he was, "Oh, no, don't worry about it. I mean, you'll be all right. Everything's locked down. The motor, is mounted to the base and all that." I said, "Okay." So we go, anyway, he went to go to turn it on, it didn't work. Now he's scratching his head. But he never thought to put the screw back. He's scratching his head because he's the master, not.
Yep.
I was telling you that engineers not artists on the most part.
Yep.
There are some engineers that artists, you know what I'm talking about. So he takes he spent all this time putting this damn thing in. He went through all that, took it right back out. We walked up to to the hardware store. But they have like a little tester that you could, it's a motor. So
Yeah.
Anyway, he took it up there, and looking at me and the two white dudes, we looking at each other, looking at him. They're looking at me like, okay, that look I was having a good time.
Yeah.
So anyway, they put it on the little test bed. Thing fired straight up.
Mm-hmm.
And then he said, "Well, I don't know why." He's going through all that. And then I was like, "Oh." Then I mentioned the screw, and the guy had said it, and it was funny when I mentioned the screw. And the white guy said, "Oh, the screw. If you put the screw in, it's not gonna spin." And the reason why is because that screw had something to do with it was a ground screw. It had something to do with the electrical.
Oh, it was an electric ground.
They put it into the screw. That screw? Yeah. So anyway,
That's
now
funny.
he looking like a damn fool. Now that screw. He said, and I remember saying to him, "Now, mind you, Mr. P, I'm not trying to be smart. That's why I don't be trying to be smart. And I wasn't trying to be smart, but I understand that when I'm building things." And they giving you a certain, unless they say you have an extra screw,
Yep.
because they tell you that in instructions. If they ain't mention no extra nothing, when you're done, all your parts got to be in place.
Yep.
Well, you see what I'm talking about? How I learned from stupidity and people, egos and all this kind of and stuff.
Yep.
Because I don't like ego. Because for one thing I learned is ego gets nothing done at the end of the day, on the most part.
Yep.
I mean, you're going to get a lot of stuff done. Don't get me wrong, because to me, ego is just a whole lot of confidence on the most part, or want to be, or whatever.
Yep.
But anyway, my thing is, to get back to this gravity thing, I want to add everything, because first of all, one of the things that caught that got me to take a look at water is because our planet is largely made up of water, not made up of water, but have water on it. We have more water than we have land mass. You know what I'm saying?
Yep.
So my thing is, how can we dismiss water when it comes to the production of gravity? How is water playing a part in gravity? And then on top of that, Mr. T, they say the planet is spinning, but the problem is that the water, and you can do this experiment yourself. You take the water, put it in a cup, and spin it. Like take a bucket that got a handle, like a bucket with the handle on it. Take the water, take the handle, tie some string onto the bucket, fill the bucket up, hang it up, and then take that bucket and spin it, and watch what happens. You know what I'm saying? And you will see that you will basically create a whirlwind. The water is not going to sit still in that bucket. The water is going to spin, and you have like a little whirlwind. But the thing is this: if we're spinning like they say we are, because they didn't say we were just all over the place, that we're basically stationary spinning, and we're doing two things: spinning and rotating. That's what I was taught in school. The planet is spinning, and then it's rotating around the sun. You know what I'm saying? I mean,
yep.
We're spinning, and the whole planet is moving. However, if you do and then that thing I was talking about doing the gravity with the bucket of water, when you swing it around, the water stays into the bucket. Well, you and I both know that's centrifugal force. Force is doing that. Okay, now when you take the bucket, hang it up, and then spin the bucket and look and watch the water, and notice that the water is moving in the direction of the spin. But in reality, this big massive planet, and when you see storms and stuff, and not even storms, you notice how you never see that the water's trying to spin in the direction. The water seems to be moving. In fact, the water seems to be responsive to the gravity on the planet more so than some identifiable spin of the entire planet. Does that make any sense?
Mm-hmm.
So my thing to the flat earthers, which I'm not stealing them either, but you know what I'm saying, but I like a lot of the stuff they do because they challenge your thinking. And yet, if we're spinning, there should be results at the speed that they're telling us that we're spinning at, you know? And I'm not saying that we're not spinning because I believe that we are. Some just tells me we're not spinning as fast as the calculation state, you know? I don't know. It's just a lot of...
Well, I'm pretty sure we're spinning as fast as calculation state if the size of the Earth is what they say that it is. If the measurement of the Earth is accurate, if the scale of the Earth is accurate, then the speed of the Earth's rotation has to be accurate.
Let's say if what they're saying that based on the size of the planet and the speed that they mentioned that the planet is moving.
Mm-hmm.
Okay, that's it. They're 100% correct. The problem is the movement of the water is in conflict with the spin. That's what I'm saying.
In what way? The movement of the ocean is in conflict with the spin?
Exactly. And what I'm saying is this. The ocean has a tendency, and it's funny because when I was working at the job, you work in janitorial, is that right?
Yeah.
Okay. Now, when you're walking around with your mop bucket full of water, and if you're walking at a certain speed and you stop, what happens?
The water spills.
It spills.
The water spills, right.
Now, yeah. Okay, now check this out. Now, so they figure that out. So they put that little wave break thing in there that kind of keep that from happening. See, the point I'm trying to make is this. If the water is spinning, like I said, it'll be going in one direction. Like even when you're walking, the water is going in the one direction
Right.
until you stop. And then when you stop, what happens? The water's still moving in that direction.
Right.
Okay? And so because of because of when you stop, everything stops because you stop. So the water still moving in that direction. Then what usually happens when it hits when it spills, and you look at the water goes back.
Right.
When you stop, the water moves forward first, spill, depending on how high the water is, but then the water has tendency to move back. And the only reason why it's doing that is because we know there's gravity. But here's the part that's kind of interesting. The reason why it did that is because you stopped. Meaning that ocean waves are moving backwards, forward, side to side. You know what I'm trying to say?
Yeah.
They're not really moving, the way, based on the way, because remember now, the way the Earth is spinning, we already agreed that their calculations are 100%. Okay, we can go there. But the thing they're saying is, we're spinning like a ball horizontally. The ball ain't just all over the place. You know what I'm saying?
Yeah. Well, my understanding of gravity has nothing to do with any of that stuff. Everything you just described is not the way that I perceive gravity. So I've never agreed with any of that crap. So and in the way that gravity works in my head, it doesn't contradict the way that the science describes the Earth's movement and everything. Because the way that I see it, the rotation of the planet, the gravity of the Earth is 9.8 meters per second because of the rotation of the Earth. I have always believed that if the Earth stopped spinning, our gravitational force would increase. Not because the mass of the planet has increased, but because the outward centrifugal force of the Earth is trying to throw everything off of it, and everything is being held down by gravity. So if the Earth stops spinning, that force of gravity would crush everything. That's the way I see it. The oceans, the waves of the ocean is generated by the movement of the actual moon. That's literally what creates the movement of the ocean. The water, the ocean moves because of the moon. The oceans don't move because of the movement of the Earth, because the movement of the Earth gives the water a constant velocity. It's just like being in a car. When you're in a car moving at 60 miles an hour, your motion is not relevant to the car until the car changes its direction. And that's kind of how the spinning of the Earth is. The spinning of the Earth makes everything constant. You know, that's how I've always seen it.
Yeah, and what I was saying about the water and the movement, see, let me say this. I'm not buying in the spinning of the Earth because we already kind of on the same page with that. That gravity on our planet is not being produced by no spinning on no damn planet. Okay,
Right.
that's not. I think we have come to a conclusion of that.
Yep.
And the thing about it,
That's why I focus.
like you said,
That's why I'm focused more on not trying to understand stuff that I know isn't true, and I'm focused more on gravitons and neutrons generating gravity. Using.
the only reason why I'm doing what I'm doing is because remember what I said about when you leave things out. Because see, sometimes this is like because I'm lost. First of all, what other science do we have other than theirs? Which is not bad because at least somebody started to do something.
Mm-hmm.
But it means that you take on what's already out there, and and information is always tweaked.
Yeah.
I put it away. People that are actual true scientists, they don't grab their information as if it's religion. You know what I'm saying?
Yeah.
They're willing to grow. It doesn't matter. I mean, I could be studying gravity like even you. Let's say right now you're studying gravity and you come on some good theories, a whole bunch of stuff. You know what I'm saying?
Yep.
Then you wake up one day and you're 90 years old and you discover something that just debunked everything that all those years that you had invested. You know what I'm saying? So the thing is, what do you do at this point? Do you do like religious people do? Do you ignore the fact because it makes you feel bad because you be thinking, damn, I just wasted 90 years of my life. You know
That's
what I'm saying?
That's pretty much what the charged neutron was.
Right.
The charged neutron showed me that the force of attraction is inversed. That opposites repel and like charges attract. So, yep.
And see, that's the thing. And see, my thing is, and I get that because it does make a lot of sense. See, the thing I was trying to okay, me personally, gravity is energy. Period. To me, you know what I'm saying? It has nothing to do with the rotation of the planet itself. And not to mention, let me say this: when it comes to the rotation of the planet itself, that is a whole nother uniqueness that I find very interesting. That the planet will spin. You know what I'm saying?
Yep.
That's a whole nother situation because you're talking about the planet is actually functioning like a what they call that in a motor, the thing that spins. I forget what you call the part in the motor that spin. Because you notice how they make reference to the planet Earth having axis, like an axle. That's all it is, axle for axle. That we're spinning like on an axle. You know what I'm saying? I know they call it axis. But the thing about it is this. That's what an electromotor does. The Earth, there was a commentator, I think it's called a commentator. But the point I'm trying to make is the Earth is actually functioning like a brushless motor. Okay? And I find that to be interesting in itself. Now, I will say this. The energies that is causing the Earth to spin, I'm pretty sure plays a big part in the production of gravity. Because we don't even know what's actually, because they keep saying we're being turned by a magnetic. I'll put it this way. You ever notice they never say that we're being turned by a magnetic field. They just make mention that the Earth is a magnet and that the Earth has a magnetic field. But the question is, we get that, but what's making the Earth spin? Now the question is, what I find interesting too is the moon doing the exact same thing too?
No, the moon doesn't. The moon doesn't have an iron core.
Okay, so that means that the moon is just. Now this is what's interesting about the moon. Now the moon, like you said, the moon don't have an iron core. So the question is, from what I understand, the moon is also moving with us. Is that right? Or is it just sitting there?
What do you mean? It's moving through space and it's attached to us.
No. What I'm saying is,
The moon orbits. Yeah, the moon. The moon both spins and orbits.
It's orbiting. So
Yeah.
with it, okay. And then here's the thing: you say it doesn't have an iron core. So the question is, what's holding it in its orbit?
Gravity.
Is it
The moon is held in its orbit by gravity.
okay.
I'm serious though. I know that sounds kind of counterintuitive.
No. What I'm saying is, so you saying that the Earth has an iron core?
Yes.
Okay, but the moon don't.
Yes.
And how do you know that?
Because scientists said that. The scientists that studied the rocks of the Earth, of the moon, they claim that the moon doesn't have an iron core because it doesn't have a magnetic field.
I like when you say claiming.
Yeah.
Okay, I got you.
I don't waste energy trying to I don't do semantics because I don't Cornell, I don't even know if the Earth has a magnetic core. like I don't know if the Earth has a magnetic core. There's no point. Yeah.
Because you notice I never mentioned the core. What did
Yeah.
I say about the Earth core? I said we really don't even know because nobody actually dug to this core.
Yeah.
Okay. Now the reason why I responded to you the way that I responded to you is because you just let me know that the moon has no iron core. I never asked that. You know what I'm saying?
Right.
You brought that up. Now my thing is that's why how you know because I know based on what you said, and I knew your response was gonna be science. But science also has taught me that unless they're lying or holding information, that no one has actually dug to the center of the planet, of our Earth.
No.
So my thing is, wait a minute. We speculate what's in the center. But my thing is this, Mr. K, until you're there, speculation
So
is just that.
The scientific proof that the Earth has a iron core was done with seismograph technology. They sent radio waves through the core, through the planet's core, and they used those radio waves to calculate to determine the fact that the core of the Earth must be solid. Now, the radio waves that they used to measure the Earth's core was the vibrations from earthquakes. They used the gravitational seismograph all over the planet because during the back in the day when they started making seismographs to calculate the movement of the Earth, they globally synchronized all of them together. And they noticed that earthquakes were occurring at the same time. So they noticed, like in New York, there was an earthquake if there was an earthquake in Japan. But the thing was that the earthquake in Japan was the seismograph went off in New York relative to the earthquake in Japan, and the strength and fit quick and everything was relative. They started noticing that the everything was consistent, and so by doing that, they discovered that the seismograph equipment the seismograph equipment works by measuring the movement of the Earth. It can actually measure the actual Earth's movement, right? So when the ground shakes, the seismograph technology can calculate how much the Earth actually shook.
Okay.
When the vibrations travel through the planet, the seismograph technology can calculate the shifting of the actual planet through that reverberation. Over time, they were able to calibrate them to eliminate background noise and stuff like that. Because seismograph technology is sensitive enough that it'll pick up a car driving by. If you put a seismograph next to the side of a road and a car drove by it, it will calculate that actual reverberation. You know, so that's how they actually work.
The reason why I'm saying this, and because it goes back to, remember what you had said about when you just mentioned about the semantics and I'm not putting no energies and all that stuff.
Yeah.
And I get that because that's the way I'm trying to approach what we're doing. And everything you said, I get it. See, herein lies the problem with that. You know, is first of all, when you were talking, I was thinking about a rapper.
About what?
A rapper, like a rapper and rapping, doing rapping.
Yeah, rapping paper.
Songs and stuff like that, rapper. And then I thought about singers. And the thing that I found is they go into these what they refer to as soundproof rooms. You know what I'm saying?
Yeah.
The soundproof. And I was noticing that when you walk into one of those booths, and I've always been amazed by the noise that you can produce in that booth. And yet you close that door. And it's funny because the shape of the wall, well not the wall, but the situation you put on the wall to deflect and move the sound, basically bouncing sound around, that on the other side of the glass, you hear nothing. Okay? You hear absolutely nothing. Okay? So I say that to say this. I get what you're saying. It's just that with the instruments that you're using, because I just asked you what that was. I actually knew, and you know I knew. But I just wanted, the point I'm just trying to make is this. The question is, even measuring the movement of the earth, but when you send in a signal or frequency, like, because they have that machine where you hit the ground, and I used to hit the ground, but anyway, my point being is this. How far down deep is these signals and frequencies going in order to make a real accurate measurement on whatever it is they're trying to do?
So
like the soundproof room,
what happens?
Yeah.
So what happens is that when the sound waves travel through the earth, they it's kind of just like the sound booth. They don't travel through the core. So what happens is that instead of the sound reverberation should travel in a perfect. It should travel. It should propagate out from its source in a perfect cone and hit every seismograph in that area, but it doesn't. When they looked at the actual data, the seismographs always look like a donut because the sound waves, they don't go through the iron core. And then there was other instances where the shock waves were actually being reflected off of the core. So you were getting reverberations in areas where you shouldn't, based on the fact that the seismic event occurred in this area, but now this seismograph is going off and it's at a 90-degree angle from, just as an analogy, it's at a 90-degree angle from the source. So it emphasized that the sound waves reflected off the core, and that's pretty. The basic gist of what I'm trying to say is that the way that they say, the reason that the scientific evidence for the Earth having a iron core is seismic activity measurements. So I don't know how to I don't I, Cornell I
I'm
don't
not trying to get you.
I
What
don't
I'm
waste
doing
my
is this.
time. I don't treat
Well,
science like religion. I don't waste my time
no,
arguing with it. You know.
see, you don't do that either. You know I don't do that. I am a scientist, and the thing is this. Okay, now this is to everything you're saying, and that's almost an insult you bring in religion. But the thing is this. You know I'm a scientist, and you know I'm an engineer, and you know I don't play when it comes to investigating. I look at everything, and even possibility that most people don't think of. Like when you say I don't, because when you say I don't waste my time, that sounds more like religion. Because you see, I am wasting my time because I need to make sure everything is right. Here's the problem with what you're not what you're saying, but with the science. I'm not saying the science is not useful. The problem is this: the man or company mine the earth right now and extract iron out of the planet.
Mhm.
We know iron is there. Now here's the problem having is we don't even know how deep this iron is. Basically meaning that who say that there is a big cluster of iron before you get to the core that can be almost the size, almost like a coating, like meaning that the core itself may or may not even be iron. But all I'm saying is, if there's a substantial chunk of iron deposit that's in the planet that's almost mimicking or almost the size of what we perceive or believe or with our instruments of reading, we could be a little bit deceived, not intentionally, because see, I love science and bouncing sound waves. And I'm gonna say another thing that when you was talking, what I was thinking about, it wasn't no religion. Okay, what I was thinking about was this. I watched a little 101 quantum physics where I find it interesting that they were doing exactly what you're basically talking about, and they were showing how the pattern of the sound waves. And I think you might have seen this little experiment they do where they had a little hole and they would see how the pattern
Yeah,
would go through
the double slit experiment. Yeah.
Yeah. So what I'm saying, and I'm not letting, don't get me wrong, Mr. P. The instrument that you're talking about and all that you're talking about, trust me, I get it. The thing is because I'm not a person of religion, I look at that, because one thing I do know is this. It doesn't take much to trick our equipment. You know what I'm saying? And I remember when I was watching that, and it was very interesting how they were talking about how the waves were intercepting and all this stuff. And then on top of that, I remember I was watching this one thing about quantum physics where what I found very interesting, well, I don't know if you've seen this, where they were actually trying, they got names for it, but I can't think of the names because, it was my first time actually getting into this. But I remember when the lady that was doing the presentation was actually explaining how they actually tried to really record the activity of what the atoms were doing. And what happened is it was almost as if the atoms knew what they were trying to do, and they would do this other pattern, like the pattern. But then when they would turn the equipment off, they would go back to doing this one particular pattern where it would bounce all over the place because it's going through these little holes, but yet it's all over the place on the other side. And they were trying to figure out how that happened, so they tried to have they had some like filming equipment, whatever they were using, and it seemed like the atoms started getting kind of smart because it wouldn't do anything. And in fact, I think I sent one of those
Yeah,
Your opinion.
I've seen that. I have my
But
own theory on what's happening with the double slit experiment, but I keep it to
yeah,
myself because
yeah,
I know people when it comes to the double slit experiment, I know people
right.
they like the idea that the universe is mysterious. So I don't really try to challenge the double slit
Yeah,
experiment.
and
So
so what I'm saying is this. I get the thing about the instruments and stuff, and I'm gonna tell you, being a person like for instance, right now I'm building a flying saucer, okay, and I am using traditional technology. I don't have the knowledge and know-how to produce what we're talking about, this anti-gravity. You know what I'm saying?
yeah.
So I'm using just regular traditional technology. However, as we speak, what I'm having is an issue based on the technology I'm using. I told you it's an old technology. I'm trying to get this thing to move forward and backwards, and also from side to side. You know, left to right and right to left, forward and back and forth. You know, and that's what I'm trying to do. Basically, I'm trying to create a control system. You know what I'm saying?
Yeah.
And the thing that's interesting is that in my mind, I have a way to do it because I understand aerodynamics to a point. But what I find is that sometimes, even though what I know and what I think I know, you know, always something totally different when I actually do a practical application. That's why I don't do religion. When you got the religion thing up, that'd be the last thing on my mind
I
because at the
just
end of the
don't
day, I want it to work. But I get what you said about religion part.
when a
Yeah,
scientist gives me data,
right.
I don't reject the data. I don't even care if even if the data doesn't sit well with me. Like a good example is virtual particles.
I don't reject it, but I
Does
will scrutinize it
the scientists
if it's
say
not there.
yeah, the scientists say that virtual particles are a thing. Even though it contradicts with the most fundamental component of science, which is energy cannot be created nor destroyed, only change from one form to another. I don't reject virtual particles. I would never just say that, oh, well, virtual particles aren't a thing because they're not real because that doesn't make any sense. Instead, I try to understand the things about it that I don't understand. The things about it that I don't like. Those are the things that I try to understand. You know, and that's pretty much why I said what I said about the seismograph thing. There's a lot
I'm not
of there's a lot
dismissing
of
the technology. Trust me,
well, there's a
I'm
lot of
doing that.
flaws in it.
That's not what I'm doing. I hope you don't think that I'm doing that.
No, I don't think you're doing that. I'm just saying there's a lot of flaws in it, but I'm not gonna use the flaws as a way to dismiss the claim. Just like when you're saying how the fact that
What
we
I'm
use
saying is when you, yeah, and I hate to cut you off, but I don't want to lose my train of thought when you about to say what I'm, you know, my point is this. I'd already, okay, when you mentioned about the Earth having an iron core based on science
right,
and equipment they developed for this science,
right,
all I'm saying is I understand how that technology works, but it does work, and it's very effective. The problem is doing what I usually do, and like right now, you're going off of that. I'm not saying not to dismiss it. All I'm saying is that there's a possibility that the Earth may not be made, the core may not be iron. It may be something. I'm not saying it's like this. We can go with the basis that the core is iron.
right,
You know, all I'm just saying to you is
and
we only know that based on the equipment that
and
they designed, and that's
without
pretty much it. And the science
mm,
behind it. But the bottom
Mr.
line
A,
is, yeah, until we
what
get to the core, we can never know because there's probably minerals that's never been discovered because it's so down deep. I mean, so deep into the earth. That's all
so
I'm basically saying.
so
Yeah.
I'm gonna say
And that has
something.
nothing to do with. Yeah, go ahead.
So I'm gonna say
I just want to
something.
get my thought.
I'm gonna say something insulting, but I don't say it in disrespect.
Okay.
The point that the claim that you're making, in my opinion, is no different than the same position that flat earthers make. We can never go into the Earth's core and say unequivocally that there's an iron core. And in my opinion, there's no reason to
Why
even
are you accepting that fact with knowing that? That's the insult.
that
Being
that
insulted should be on your behalf,
well
not mine.
the reason why is because
You just pointed out.
that's how science works. But see, that's how science works. Like science works because we acknowledge the way that the principle was created. We don't waste. I don't want to waste my energy.
Scientists kicks the open mind. That's what I'm saying. When you say I'm not gonna waste my energy,
Right, but there's.
that's to me saying that you're not having an open mind. That's just me saying that.
I know. I get where you're coming from. I get where you're coming from. The reason why there's this position. The point that I'm making within the context of of how we're speaking is you're not wrong in saying that it's possible that the Earth's core is not iron, or what we believed that we know about the Earth's core could be wrong. Science is all about acknowledging the fact that the principle or the theory that we have is wrong or may be inaccurate. But the point that I'm trying to make, or at least the position I'm trying to establish for myself, is that I accept the terms and conditions of the method that was used to show proof of the iron core, and I will not dismiss the proof to justify the invalidation of the iron core. What I will do as a scientist is I will create. No, I'm just saying. I'm just saying from the. I'm trying to put it in context. Yeah, I'm trying to put it in context. What I do as a scientist is I will create another proof to validate or invalidate that proof. So instead of saying seismograph technology doesn't work or is inaccurate, so that doesn't validate the iron core theory, what I would do is I would create another proof to validate
There's only
the iron core theory thesis.
only one way to do it, and you know how I am. There's only one way to do it,
And what's that?
and you know how you have to dig to the damn core.
Right.
If it takes you 100 years to do it, because my thing is this, I wouldn't create another instrument to be measuring anything. My thing is, I'm going to the core. That's me as a scientist.
Right. That's fair.
I get what you said. I think
That
this myth,
that's
technology, the bottom line is,
that's
flat earthers, I don't want to be compared to them because my
that's
thing is,
that's fair.
I
As
want to
long
go
that's
planet
fair.
where you use what is the word? Imperative.
Right.
Imperative, meaning it's real. The flat earthers, the stuff they're talking about, to me, a lot of it is based on fantasy and stuff.
Yep.
The bottom line is the argument that we're having, musically, all it takes is digging to the core
Right.
to know exactly what's there. And that's it. I'm not saying that,
Yeah.
don't get me wrong, the instruments that they're using does work. That's without a doubt. I love science. But you know what? Let me say this. We know that the flaws are going to be there. There's nothing wrong with that.
Yeah.
Because the best thing about science, and because most of the time, what makes you a scientist is the fact that you don't know.
Yep.
The science is the science is like the art of studying something
Right.
that you don't know. Because as soon as you say, like for instance, we try to figure out what the hell is gravity and how
Right.
to create it. So the thing we have to do is, we right now, in our conversation, is creating a science.
Yep.
Because there's no real serious science on what the hell is gravity.
Yep.
Gravity is a speculated topic. No one knows. We get into the imperatives of how to get that.
Yeah, empirical.
We're talking about real down stuff. You know what I'm saying? So, and that's why so I wasn't dismissing anything because I need all that stuff that they
Yeah.
got. You know, with the seismic graphs and all. I've heard so much stuff that they're using, and the stuff is good. You know.
Yeah.
But the bottom line is the only
And
thing I have with the white folk is
I'm not.
they get to this when they start having an absolute type of mentality. I don't like that.
Yeah, I'm not. I wasn't comparing you to flat earthers at all. I don't want you to misunderstand that. I think it's important for me because of what I'm doing to build a proof. That's it. Cause you asked me a question, I gave you an answer, and I don't. And it's not a personal thing, but the way your position came off as dismissive because instead of saying, okay, I can understand that proof as a validity for how the Earth can have a magnetic field and the Moon cannot, you dismissed it by validating it with another proof, because you did. You validated it with the scientific proof until you physically touch. Well, you did. No, what I'm saying is, this is what I'm trying to say. This is what I'm trying to say, Cornell.
Yeah. Right.
It is absolutely scientifically true that seismograph technology has shown proof that the Earth's core is an iron core. It is absolutely scientifically true that without physical observation of the Earth's core, the data that supports the idea that the Earth's core is a solid iron mass is invalid. The reason why is because I study quantum physics. And we literally just had a conversation about the uncertainty principle. We literally just had a conversation about the uncertainty principle. Because based on the uncertainty principle, go ahead.
I just wanted to say this when you talk about the iron, the core being iron.
Mm-hmm.
The reason why I was saying what I was saying is because remember now we come from two different generations.
Mm-hmm.
In a sense, I'm saying, and the information that I have now, I mean, I'll put it away. The information I had then is different from now.
Right.
Because when you say core, I think of something solid. You understand what I'm saying?
Mm-hmm.
See, when I was coming up, when we was taught about the core, that it was hot and it wasn't solid. If you look at any of the old history books back in the 70s, the core was always hot and not solid.
Well, that's the thing about it now. It's still the same way. The Earth's core is still the same way. It's still there's a solid crust, a liquid mantle with an iron core. The iron core spins inside of the liquid magma, and that is the electrodynamo. That's how they define the electrodynamo, because the iron core is a giant rare earth ferrous material spinning around inside of a liquid, fluid, conductive, semiconductive material that generates the magnetic field of the Earth. Because remember, the magnetic field of an iron, if the Earth was just a solid iron core, just a solid mass, it wouldn't have a powerful magnetic field. Think about it, if the Earth was just a giant magnet, its magnetic field would not be as big and as massive as it is in relation to the Earth.
Now, when you talk about science,
the Earth's magnetic field.
I would have to, in a sense, how would I put that? When you rebuttal, a rebuttal would be that's not true, based on science. As you say, science, and that would be called a magnet. Magnets are solid, and these magnets are so. And I'm gonna tell you like this: the a magnet. All it needs, remember we talked about light waves, all this kind of stuff.
Yep.
All I'm saying is this: a solid. These little magnets I be playing around with, they come with warnings. Okay, the bigger they get, the more dangerous they get.
Right.
These magnets are known to break bones, literally, and it's not even a joke. I'm sitting up here right now, Mr. P. I got cuts from not cuts, but pinches where I was literally bleeding. Because of the magnets I have, besides that.
Cornell.
What you're saying, yeah.
This is what I mean. You've been to, remember when you used to go to the scrapyard?
Right.
The magnet that they use to pick cars up with? Remember how you huh?
That's called an electromagnet.
Right. Now the point I'm making is, remember how you yourself said when they turn that magnet on, the metal will literally leap up off the ground and attach to it?
That's right.
Now, it's true that the strength of a solid state magnet can vary based on how it's manufactured. But it's also valid based on our experience dealing with solid state magnets that proportionate to their size, a solid state magnet is always relatively weaker than an electromagnet of the same size based on the power input that you can put into an electric magnet of a similar proportionate size to a solid magnet. And that's the point that I'm making with the Earth. The Earth's core is extremely powerful. It's extremely powerful as a magnet. But relative to its size, its
Right.
magnetic field is generated by its rotation inside of the Earth. Whereas where the liquid mantle around the core is producing an electromagnetic field in the same way that an electric motor works. Because it's spinning inside of that medium, and that medium is conducting the magnetism, and that magnetism it's amplified by the actual size of the Earth. It literally amplifies it, and that's why the field is so powerful. You know,
And you know
that's
what that
that's the
means
way
is
it's been
that,
described to me. You know.
yeah, no, no, I mean, I get it. I get it. Because remember now, when we talk about science, and I've been doing this stuff forever. Do I have
Hmm.
all the answers? I don't have the answers. I only go by, I'm going to be honest with you. That is the reason why I don't do fantasy well, and most definitely religion. I don't do that at all. You know, as far as putting anything into it. Because when you was mentioning about, remember now, I'm over here making, I'm not making electricity, but I'm sitting up here creating electricity. You know, take argument. You know what I'm
Hmm.
saying? And what you were saying, I get. Because now, this thing, I'm going to be seeing me on that tape when I'm spinning the magnets to get the electricity I need to power the LED.
Yeah.
Now, this is what's interesting, because when I'm saying what you're saying, now, the component that's producing all this stuff is the core in the center that's spinning. You know what I'm saying?
Right.
That's spinning to produce the magnetic field. Is that what we're talking about? The magnetic field that's being produced?
Yes.
Okay. Now, see, here's the thing I find interesting. When it comes to, because remember I told you about the way a magnet is made from the rare material, it's like the rare material. They actually, because I know how to do this. I know how to make a magnet. You make a magnet by energizing it with what? Electricity.
Yep.
Okay. So when you was making mention about how this iron, you know, the situation that's taking place in the center of the earth that's spinning, that produce the magnetic field.
Yeah.
The thing I find interesting is, I don't know how to put this. It's like this. That action, first of all, let me say this. Now, this is my experience, okay, when it comes to creating a magnetic field. And this is what makes magnets so unique. First of all, you don't need a piece of material spinning to create, to where it will, either pull or take, to create a magnet by spinning something. You know what I'm saying? Like a piece of rock or whatever. Magnetism is interesting because all you need is a piece of material, like a piece of mineral or whatever, just sitting around electricity. If electricity is close enough to it, it don't have to even touch it. It just got to be close to it. Just enough where the magnetic field will be absorbed by the material. Meaning that a magnet don't have to spin in order to become a magnet. So when you're saying that this thing is spinning to create the magnetic field, anything is possible. I don't rule that out. It's just that from my experience and understanding, fooling around with magnets, think about it. I didn't learn how to make a generator overnight. And there was a lot of stuff that I don't know now. There's a lot of stuff that I've learned and things I had to do in order to get that thing called Eureka, where I actually spun something and created electricity. But the thing about it is, now I moved the magnet. I was moving the magnetic field, but you were saying that the center is creating the magnetic field. From what I'm listening to you, that spinning action that's taking place, because you give all those terms and all that, I'm not.
Yeah.
So I'm just saying the iron material that's in the center that is spinning is producing this extraordinarily strong magnetic field. And all I'm saying is that mineral, you don't have to, no matter what it is, it will become magnetized. My friend, I don't know if you ever see, you probably have in the second grade science, where they take the wire and wrap it around the iron nail.
Yep.
And then you let a battery, hook a battery to it.
Yep.
And what happens is how that coil that you wrapped around the battery, well, the magnetic signature that comes off that cord, the wire, is absorbed into that metal. So when you let the battery go, like when you shut the battery down, unlike an electromagnet, when you let that battery go, that piece of iron is still magnetized. So anyway, I get what. Mr. P, don't think I'm being insulting.
No, I know you're not. We're literally Mr. A. You and I are having an adult conversation. You and I are having an adult conversation about science, and we're not trolling each other. I think that's the main reason why I took the time out. Yeah, that's the main reason why I took time out to explain where I was coming from, because I know we spend so much time talking to people that are disingenuous that I didn't want you to be insulted by a statement that sounds hostile. But it's just that's how you have to. Sometimes in science, you have to challenge your own comfort zone to move beyond your own comfort zone. And by telling you, like, you kind of sound like a flat earther, it wasn't really to be mean. It was just to help you move beyond your own comfort zone, because you're not a flat earther. You know that what you said isn't invalid. It's just I'm telling you how it sounds to me. It ain't got nothing to do with what you said. That's just how I'm interpreting it, and by saying that, I felt like it would help you to reword it and readdress it in a way that we both could come to a better understanding, But because we spend so much time dealing with stupid people on the internet, I just wanted to clarify. That's why I said I'm gonna say something that's gonna sound insulting, but I don't,
The thing is, see, this is where I'm at with all this. The Caucasian science is the only science that we have to work with.
Yep.
And my thing is, and that's fine, they started it, and that's fine. The only thing is this. Like we were saying, how you was approaching by using that to get out of my comfort zone, well, that's almost like, I'll put it this way, that's kind of like what we're both doing to each other. You know what I'm trying to say?
Yeah.
Because on the one hand, we talk about how much power that we give the Caucasians by accepting their everything when it comes to science and everything. You know what I'm saying?
Yep.
So what I'm saying is this. If we're going to do this, and if you want to have me to help you, well, guess what? There will be times where I will never reject their science, at least not, I put it away, reject it to the point of not listening to it. Now, I may reject it as far as not applying it, you know what I'm saying? Because it's kind of like some of the stuff that they do and say, you have to use your common sense, because science you have to be careful with science. And what I mean by that is this. It goes back to that guy that warmed the gas station, to warm his gas for his car in the wintertime. You see what I'm saying?
Yeah.
So, my thing is this. He had a good idea, and the logic was all there. You know what I'm saying?
Yep.
But the problem is, the logic was based on ignorance. See, you know what I'm trying to say? Because the bottom line is this. Yeah, the problem is like this, your gas tank, the fuel line, because it does happen, and it's annoying. But see, no one taught him that, or he didn't know, whatever, is that it's water that's clogging your line, not the gas, because the gas don't freeze. It's the water. Then the question is, he'll say, well, I didn't put any water in the tank. Then you have to explain him about condensation. You know what I'm saying?
Yep.
The water comes from condensation. Condensation is a situation that takes place when you have moisture around and metals that are, when we're talking about the temperature, there's a lot of stuff that will produce water for you. It's a natural process. So there's really nothing that you can do to really prevent your tank from actually freezing up. The only thing you can do is just to make sure, like I always tell people this, make sure, understand, gas doesn't freeze, okay? However, keep the line full.
Yep.
You know what I'm saying? Don't let no air spot, don't let no air pockets get in, because that's where the moisture from the condensation will take place, and that's where you will get that accumulation, and eventually you will get that clog.
Yep.
So the only real, because if you sit up there with some heat, now you're talking about igniting, because I always try to explain to people that the liquid gas is not what burns, it's the fumes.
Yep.
Is what burns, the gas. That's what burns. What you can't see is what burns. The gas you're looking at does nothing. I mean, it can do something other than stink, but it's what you can't see, and that is what's coming it's the fumes that's coming off the gas. And it doesn't even matter. It's like if you got that gas sitting somewhere, fumes are naturally coming off because that's a composite. It's breaking down. That's why it's doing that.
Yep.
It's really evaporating. It's evaporating just like water.
So,
It's
Mr.
going to
A,
naturally do that. Yeah, I'm sorry about that.
no, you good. We've been at this for like
a
an hour and a half. So,
you know what? I'm blaming you on this because I ain't never thought about no damn gravity. You know what I'm saying?
Mhm.
And see, I hate when folks do me like that. You know what I'm saying? Because I love this stuff. You know what I'm saying? And I never really thought about gravity. You never notice every time you call me, you're talking about stuff like this. And I noticed you've been talking about this gravity thing for a while.
Yep.
And you know, I just mainly listen to you. You notice how I just listen to you?
yep.
And I never really said much.
Yep.
Now you see why.
Yep.
Because once you get my little brain going, it irritates because I got other things to do.
I know.
I love a good mental challenge, you know what I'm saying?
Yep.
Because my mind, because I got 50 years of
Just-
studying.
just-
I grew up with encyclopedians.
Just
okay?
wait until you start mixing gravity with hydrogen. Then you really gonna be mad at me.
Trust me. I'm already looking at them landing that thing on Mars, and you already felt kind of slighted because I'm not there. You know what I'm saying?
Yep.
I mean, niggas want to be in the control room. You know what I'm saying? I mean,
Yep.
mission control. Niggas be trying to act like, wait, that's a nigga over there smart. I ain't trying to be over. You know, I'm just there want to be up in the room. Just maybe can I get in? You know, and that's the thing I hate about not being in, because I actually want to be there. You know, I actually want to sit around and listen to the talk, see the equipment, the instruments, because the technology, and that's why I ain't sat down. I ain't dismissing the technology, the seismograph and all this, because it was amazing how they set that bad boy on that planet. You know what I'm saying? So I like, even if it's a fantasy, oh, that's not true. I read the thing. It's a whole, you know what? Now you see how I gravitate towards that. We keep telling you, my friend. So my thing, okay, you prove it's like this, until you, it's like this. You're telling me that it's a hoax and showing me all the stuff that you're doing, it's still not good enough. I'm listening to you, but every time you tell me, because I have an engineering mind, so I'm trying to fix things. You know what I'm saying? So you're telling me, because I can't fix religion, but I can fix what you're talking about, because at the end of the day, you're not going to know, Mr. P. I know how to make things fly.
Yep.
Okay? I know how to do that. And what these guys are talking about doing, or what they have done, or claim to have done, well, my thing is, all these flat earthers, my thing is, look, y'all, I'll tell you what, come on over here. Y'all want to know if the earth is round. Y'all say there's a dome. How many of y'all put y'all money together, and we will, and y'all have a black man on the team? You know, a team and guess what, Mr. Johnson, to let you go. We're not going to title this as debunking the flat earthers. Our title was going to be to prove that the earth is flat.
Yep.
Project. Okay? You see what I'm saying?
Yep.
Now, when we find that it's not, are we gonna move our egos aside and explain what our research discovered, not our personal opinion? You know,
I wonder. Oh yeah, they just said it's fake. Because I was gonna say, I wonder what the flat earthers are saying about landing on Mars, but I remember they're just gonna say that it's fake. So.
Yeah, another thing they kept talking about, why they didn't send pictures back from the Earth and all this kind of stuff. It is a whole bunch of stuff. But my thing is this.
That's stupid. You know what's funny? No, you know what's funny? They said, why didn't they send pictures back of the Earth? But Elon Musk had a car floating around on the Earth, floating around in space showing the Earth, and they like, oh, that's fake. You know, like, he live streamed a car floating around in space, and they like, oh, it's fake. I just think people don't realize how insignificant we are to the actual Earth.
Like, the mathematician, you know what I'm saying?
Yeah.
And you understand formulas and stuff work, Mr. P, it is not difficult to prove their point. Remember I said we could do a flat Earth.
I've already said.
Flat Earth is
I already,
real.
I already know how to. There's a very. I'm gonna have to make a my 2 cent video. There's a very easy way to prove that the Earth is flat, and it's super cheap and it's super easy. And remember, I told you,
Yep.
you can see the moon during the day and at night. If you can see the moon during the day and at night, and if the Earth is flat, then people could go outside with their phones and get in a huge stream, and everybody can look up at the sky at the same time, and everybody should be able to see the Earth, should be able to see the moon on the Earth. Because if I can see the moon during the day, and I'm in Washington, and you can see the moon during the day, and you're in Michigan, and someone in China can see the moon during the day, then you know what, Mr. A, let me let you go. I'm gonna make that an.
Can you do that on Facebook and see if you can get some people all over the place like Joy? Like
Actually,
Joy in the UK,
I think that's simple enough that I'm gonna make a my 2 cent video of it real quick using Blender. I think it's easy enough that I should be able to animate that in Blender. So.
Yeah, and not only that, why don't we kind of see if we can do that on Facebook to actually find people in our thread, you know, in a thread.
Yeah, in our yeah.
A guy named Benjamin, okay?
Yeah.
And he's Korean, okay?
What we need?
What's that?
We need an Australian. You know why, don't you?
I think I got some people from Australia.
You
Well, yeah, do that.
you know why you need an Australian, don't you? What you need to really disprove it, you need someone where I am, someone in like Canada, like on where I am, and someone in Australia. Because the reason why is because you need a North and a South Pole. Because the North and the South Pole are they're far enough away from each other in latitude that they're not gonna have the same sky. They're not gonna have the same sky, you know. And that's what we really need, you know. Yeah, I think I'm gonna build it.
We should try to do it on Facebook and say, if you have any relatives that live in Australia and you got relatives that live in the north, you know what I'm saying?
Yep.
And then tell them, say, look, what I want you to do is this. I want you to call your friend. If we don't find one on Facebook, that's all we think. I think a guy from that was on my thread that was from Australia, and say, what I'm gonna need you to do tomorrow at 4 o'clock, whatever, I want you to look up in the sky and take a picture. If you see the moon, and now Mr. P, you good at this, you have to tell them what direction to look. When you know what I'm saying, to take a picture, so we know that they would have to be.
It really don't matter. That's the cool thing about flat Earth. It really doesn't matter. Because think about it. No matter where you are on the Earth, you have to look at the moon to see it. So if I tell you to face east, if I say face east and the moon is behind you, well, you're not going to be able to see it. But the Earth is flat, so you should be able to see it. All you have to do is be able to see it, you know.
Yeah. Okay. Okay. Well, you know what? We should try to do that. Like to see if we get anybody to do that. To take cause you know, and then and see how. And it's funny because that would prove, right?
Yep.
That would be a cheap way to prove. Because the bottom line is, you can't be on the. It's like this. If you sit up there and saying I can see the moon, and you sit there and saying I can't see the moon, then the question is, why can't you see the moon without on a flat surface?
Yep.
That's a good idea. We should try to see how we can orchestrate.
Yeah, I think I'm gonna make a like I said, I think I'm gonna make a video on Facebook. I mean on YouTube making. When I get off the phone with you, I'm gonna start working on it. So.
Yeah, and make sure people ain't trying to be trickery and trying to take a picture of the moon, you know, like old foot
Cornell.
It's gotta be right. Yeah.
It wouldn't matter because there's more than one person in the area. If I get 2 people from Michigan and one of them says, "Oh, the moon's not out," and then one of them says, "Well, the moon is out."
Yeah.
There you go. You know. So.
Okay. Another thing too that will help too is when you do this, have the person to post the time that they saw the moon.
Yep.
Like whatever time they say, okay, at 5 o'clock, I want everybody to look outside in the sky for the moon. at 5 o'clock, and then when you do that, proof that you did or did not see the moon. So this way we get a tag on the, you know what I'm saying?
Yep.
Somebody can't be coming in talking about, I saw the moon.
You should.
Just like 5 or 6 hours.
You should.
Chris saw the moon.
You should get it started. Can you see the moon this morning?
You know what? I can't.
Cause you got an overcast.
You understand? Yeah, we got a horrible overcast right now. I'm looking up in the sky now.
Yeah, there's always an overcast here.